In the framework of the agreement about the scientific cooperation between the University of Tokyo and the Vienna University of Technology, the results of the research topic Disaster Mitigation and Security in Buildings have been presented every year since 2001. The projects of this continuous research have been exhibited also in this year. The Dean of Education, Professor Christian Kühn, and the supervising experts of the Vienna University of Technology, Professor Ewald Brückel, Landslide, Professor Wolfgang Zagler, Design for Visually Impaired, Diploma Engineer Frank Peter, Fire Protection, and Dr. Kai-Marta Vossi, Earthquake, visited the exhibition. We have been grateful to be able to welcome also the Minister, Mr. Ryuta Mizuchi, and the Cultural Attaché, Ms. Yuka Akamatsu, of the Embassy of Japan in Austria, who came to see our presentation. Mr. Mizuchi and Ms. Akamatsu showed great interest in all exhibited projects, which were explained to them in detail. In the framework of an urban design for the city of Nagaoka, the new city hall was planned by the student Markus Grundnig. Another earthquake-proof skyscraper for Niigata was designed by Thomas Rief. Concerning earthquake protection, this high-rise building by Claudia Pillich was explained functionally and structurally as well. Several high-rise buildings have been designed, but each with a different construction, like this hotel and office tower by Milen Stefanov. Even this concert hall, designed by Mariam Farsi, can be converted into a crisis center in case of a disaster. Anna Vera Deinhammer explains her design of a sports and training center in the landslide-prone area of Niigata to the Japanese visitors and Professor Brückel, who is specialized in geodynamics. This project by Michael Kist represents a new solution for a central railway station in Vienna. The possibility of studying information engineering should be given to visually impaired students. Nia Siarova is discussing her project with Professor Zagler, our expert on this topic. An alternative solution for providing workplaces for visually impaired was made by Benjamin Schneider. Professor Zagler explains the recent innovations of his research group on the field of design for visually impaired. He introduces small electronic devices, like a scanner which can distinguish different colors, or a tape meter, which gives an audio information about the measurements of an object.
The task was to design a tower building with a congress hall, offices, a hotel, and a shopping area. The building must be convertible into a crisis center to accommodate 1,000 victims in case of a disaster. The construction has to be earthquake resistant. On the ground floor, the entrances to the congress hall, to the offices, and to the hotel with access to the shopping area are separated. The building has 50 floors. 30 of them provide offices for 2,000 employees. In the uppermost 14 floors, 250 hotel rooms are available. A congress hall for 700 participants is situated in the lowest part of the building. Rooms for press and seminars are also attached. In the upper construction floor, a sky lounge with panoramic view is provided. One floor is designed as a restaurant with a breakfast room. The facilities in the basement have two different functions. in normal case and in emergency case. The drive-in leads into the car park for 200 cars. This area can be changed to accommodate 1,200 victims by means of family stands, each for 6 persons. Cars and buses can bring the victims to the central hall, which serves for registration and first aid. The onsen pool, which is available also in normal case, can be used for hygienic purposes in case of emergency. The medical center for health control in normal case can be converted into a clinic in case of necessity. In order to achieve a new type of earthquake-resistant construction, the building complex has been designed with 4 sections, 3 semicircular elements which surround a central core. The 3 surrounding elements have their own core for ducts and storage. The movement of the 4 building parts caused by an earthquake are different. On the construction floor and on the top, these parts are flexibly connected by dampers which maintain the stability of the complex and dissipate the kinetic energy by friction. According to the soil conditions, the reinforced concrete slab foundation is additionally anchored with piles into the solid ground.